Hello guys and welcome back. So I have 40 frames of the sim going, and you can see the collision is working really well. The bounding box here is not expanding, but we can add a little bit more padding to the settings, and that should fix the issue. Now look at how when the box moves through the geometry, it's adding more velocity. You can see here the temperature changing. You can see here these lines are changing as well, and all of this helps to create a much more interesting look to our sim. And I mean, if we let this run, it's going to create something really cool with all this this stuff interacting with the ground and all. And this is a very simple geometry, so if we had something more complex with more randomized velocity, it will look a lot more interesting, similar to the one I have done with the robot. Now, what I wanted to talk about is there's not so much to show you guys in terms of creating explosions. To be honest, the two things that that are key factor is you need to know the type of emission that you to use for your explosion. If it's something with tendrils, then you create the tendrils with long trails and all, and use those to source density as well as the pump force. If you have a blast, if you have something that expands quickly, this is the technique to use. Use particle, you create straight trails, and then you pump that into a uniform volume, whether it's a disc, a sphere, anything generally works. You just have to tweak the settings to give you the result that you want. Changing the original density source is going to change the sim drastically. So if you have half a sphere, for example, it's going to give you a completely different results. If you have a quarter of that sphere, if you add noise to the volume to break the density so it's not too uniform, you're going to get different result. And you guys have to try various things and see the result that you get. Now, this is pretty much all I have in terms of creating explosions. There's not much more that I haven't shown you guys. The other things that you can explore, which I personally have not done too much, is to actually look at further processing of the data. So for example, we can take the density channel, okay, let's remove this, and then we can convert that into a VDB. And we can run more volume analysis on this. Now we can create a VDB analysis, and there is various things. There is a gradient which expects expects a scalar, generates a vector. Curvature expects a scalar, generates a, oh yeah, it expects a density field. Laplacian, this is something that generates a different kind of information. So let me call this density and see if we get any volume representation of this. It's not generating anything visual, so let me scatter some points on this volume. It's the best way to view the result is to use points in general. So let me create some points on this volume, and let's append to this. So I want to compute the Laplacian. Actually, I think I need to select the density field. Okay, let's create a volume sample. Volume point VOP. Connect this. and it's a scalar field. Let's dive inside, and volume sample. Second input, and that. Cool. So let's increase the number of points. Okay, and let's dive inside, and let's fit range this. That's great. Minus. See if we get anything here. Let's view the points. So it goes between 0 and 1. So this is another information, for example, that you can use in your volume in the sim to generate new masks. For example, you can take the density field and compute this Laplacian. You can Google it. I'm not so sure what kind of data it does create, but it selects certain areas that may be interesting, and it will evolve in an interesting way over time. So the mask is not just random, it's based on the sim, which could lead to creating some interesting masks that you can use to apply force, for example. So this is one way. You can use the curvature, which I showed. These two, this I'm not so sure about, and this is for the velocity. So you can compute the, let's see if that works. So you can compute the curl for the velocity yourself and use that vector to add force to it, but you will be creating basically what the confinement, I guess, vortex confinement node does. So you create something like that. The only one that I believe is interesting is the Laplacian to use, and then the curvature as well could generate some very, very interesting data to use as mask or as temperature or anything like that. And I think that's pretty much it. Next week is going to be packed with a lot of tips and tricks, and we're going to learn how to create color advection as well as a lot of other cool things. Thank you guys for watching, and see you next week. Bye bye.